In this video, we're going to do some practice problems relating to linear approximation and local linearization. So first problem, find a linear approximation to f of x equals natural log of 3x minus 2 near x equals 1. That is, we are going to find the tangent line of that function at x equals 1. That's what we mean by that statement. So we're going to find the tangent line of the function at x equals 1. We're going to use that to estimate f of 1.02, and we're going to answer the question, is that an over or under estimate? So in order to find the tangent line, we're going to need to find the derivative of f of x. So we have our function, natural log of 3x minus 2, and to find the derivative, we're going to have to use the chain rule. Our inside function is 3x minus 2. Outside function is natural log of something. The derivative here is going to be the derivative of natural log, which is 1 over something. The something is the inside function. And we are going to multiply by the derivative of the inside function, which is going to be a 3. So we can write our derivative as 3 over 3x minus 2. Now what we care about for getting the tangent line is not so much the functions themselves, but plugging in 1 into the function, plugging in the value a into the function. So here we have f of 1 is going to be natural log of 3 times 1 minus 2, and that is going to be natural log of 1, which is 0. And that's a nice value to deal with for this function. F prime of 1 is 3 over 3 times 1 minus 2, which will be 3 over 1, which is 3. So our tangent line, our linear approximation, is going to be y equals f of 1 plus f prime of 1 times x minus 1, or in this case, we're going to have 0 plus 3 times x minus 1. So the next question is this an over, or sorry, what is f of 1.02? Estimate f of 1.02. So we are saying that our function is going to be approximated by 3 times x minus 1 near x equals 1. So f of 1.02 is what we're going to plug in to that approximation. Now we have 3 times 1.02 minus 1 is 0.02. This is going to be 0.06. So how do we know this approximation is an under or over estimate? Well, one way is that you know what the graph of natural log looks like, and you know that the 3x minus 2 is just going to be kind of moving that graph around, but it's not going to change the shape so much. Our graph is going to look something like this. And we know that is going to be a concave down function. The tangent line is going to lie above the function at that point. This is going to be an over estimate. How can we do that without the graph? Well, we can think about the second derivative. We can find the second derivative and see where is that positive or negative. So this is going to be the derivative of the first derivative 3x minus 2. And it might be nice to write this as the derivative of 3 times 3x minus 2 to the negative 1. Instead of doing the quotient rule, we can do the chain rule here, which is going to be a little bit easier. Inside function is 3x minus 2. Outside function is something to the negative first power. The derivative here will be negative 3 coming out in front, something to the negative 2 power. The something is what we're going to leave on the inside, 3x minus 2. And we're going to multiply by the derivative of the inside function, 3. That's going to be negative 9 over 3x minus 2 squared, which will always be less than 0. So that means that the second derivative is less than 0. That means that this is concave down, which means that we have an over estimate. Either way is going to be fine. If you know what the graph looks like, that's more than enough information. If you don't have that information, you probably have to do it algebraically, finding the derivative, the second derivative. Let's do a similar problem now. Find a linear approximation, that is, find the tangent line of the function 1 over square root of 1 plus x near x equals 0. And we're going to estimate f of 1.05 and determine is it an over or under estimate. So same kind of idea as what we did in the previous problem. Here our function is 1 over square root of 1 plus x, which we can write as 1 plus x to the negative 1/2 power. And for finding the derivative, that's going to be a lot easier to do. The derivative using the chain rule is going to be negative 1/2 1 plus x to the negative 3/2 times the derivative of the inside, which is 1. And again, what we care about here is not really the functions themselves, but finding the function where we plug in 0, because that's where our tangent line is centered at. So f of 0 is going to be 1 plus 0 to the negative 1/2. That's just 1. And f prime of 0 is going to be negative 1/2, 1 plus 0 to the negative 3/2, which is negative 1/2. So our tangent line here is, we can say f of x is going to be approximated by f of 0 plus f prime of 0 times x minus 0. This is only near x equals 0. So this is going to be 1 minus 1/2 x is going to be our tangent line. And I realize we shouldn't have f of 1.05 here, but how about f of 0.05? That's a little bit closer to 0. We could do 1.05. It just wouldn't be a great approximation, maybe. And we can have that f of f of 0.05 is going to be about 1 minus 1/2 0.05. And this will be 1 minus half of 0.05, which is 0.025. And this is going to be 0.975. All right, I'm just going to assume we don't know what 1 over square root of 1 plus x looks like. If you do, that's great. But let's just do it just algebraically to find if this is an over or underestimate. We need to find the second derivative. To do that, we just take the derivative of the first derivative. That's going to be negative 1/2 times negative 3/2 1 plus x to the negative 5/2 times the derivative of the inside, 1. That's using this form and doing the chain rule. Bring the power down out in front and decrease the power by 1, and then multiply by the derivative of the inside. This is going to be 3/4 1 plus x to the negative 5/2. Maybe write that as 3/4 times 1 over 1 plus x to the 5/2 power. And when x is greater than, x has to be greater than 1. So this is actually always, I should say, positive. We need a negative under the square root for that to be negative. That's not going to be possible. So this is always positive. So this is concave up, which means that we have an under estimate. Our function looks like this in some capacity. Tangent line is here, and it's going to be lying under the actual function. So one last problem. This example is going to look a little different than the one we had before, the two we had before. So the equation x plus cosine of 2x equals 0.8 has a solution near x equals pi over 4. We're going to estimate the solution using a linearization of the left-hand side of the equation. A linearization, a tangent line of that function. X plus cosine of 2x at x equals pi over 4. So before we get into the details of this problem, let's just deal with the tangent line first and have that able to work with. So in order to find the tangent line, we have our function x plus cosine 2x. Our derivative is going to be the derivative of 1. The derivative of cosine of 2x, we need the chain rule. It's going to be 2 times, negative 2, I should say, times sine of 2x. The derivative of cosine is negative sine, multiplied by the derivative of 2x, which is 2. That's going to be 1 minus 2 sine of 2x. What we care about is not the function itself, but the value at, in this case, pi over 4. This is going to be pi over 4 plus cosine of 2 pi over 4, which is going to be pi over 4 plus cosine of pi over 2, which is one of those values we should just know. This is just equal to 0. So the function value is just pi over 4 itself. For the derivative, we have 1 minus 2 sine of 2 times pi over 4. That's 1 minus 2 sine of pi over 2. We should know that sine of pi over 2 is equal to 1. So this is equal to 1 minus 2, or negative 1. So our tangent line here is f of pi over 4. This should just be f of pi over 4 plus f prime of pi over 4 times x minus pi over 4. So altogether, that's going to be pi over 4 minus, I should say, 1 times x minus pi over 4. And this should be pi over 4 minus x plus pi over 4. It's just going to be negative x is our tangent line. Y equals negative x. And I made a little mistake there. Let's do that again. This should be pi over 4 minus x plus pi over 4, which is negative x plus pi over 2. All right. There is our tangent line. And we are approximating. We're saying that x plus cosine of 2x is about the same thing as negative x plus pi over 2 near x equals pi over 4. So if I want to find when does x plus cosine of 2x equal 0.8, so to estimate the solution for this, I can do instead negative x plus pi over 2 equals 0.8, or x equals pi over 2 minus 0.8. And there is our approximation to the actual solution to that equation. If we think about what we did graphically on the next page, we have our actual function x plus cosine of 2x in red here. And we have our tangent line given in black. And these dotted lines here are the values. This was our 0.8. We're trying to find out when does that function cross the value at 0.8. And we have these two values, which are pi over 4 and our solution, pi over 2 minus 0.8. So we can kind of see, if we zoom in on this graph, it looks like the tangent line of the function are the exact same line. But if you zoom in even further, there is some separation. We can see that this is what we found here, the plugging in or setting our tangent line equal to 0.8. And this was close to what we were actually looking for, plugging in the function, or setting f of x equal to 0.8. So one of the points of these pictures is that it takes a long time to zoom in to get to this point that we can see a difference in the function and the tangent line.